Power in circular motion. Now we know the basic of circular motion. Whenever the particle moves in a circular motion, there may be two kinds of forces. One is the centripetal force, which is responsible for making the particle to move in the circle, and one is the tangential force, which is responsible for changing the speed. No work is done by the centripetal force. The work can be only done by the tangential force. This is the basic we covered in circular motion. And if the velocity of the particle is v, then the rate of doing work, that is the power delivered, is what? Ft dot v. Only the tangential force plays the role in the rate of doing work, because this force is perpendicular to velocity, so work done by centripetal force is always 0. We know the work done by centripetal force is always 0, correct? So this is something basic we will be applying in this problem. So a particle of mass m is moving in a circular path of constant radius r, such that the centripetal acceleration AC is varying with the time, as AC is equal to k square r t square. So we are given a model in which your particle is moving in a circular path. Okay, you are given a model in which your particle is moving in a circular path, and you are given the expression for the centripetal acceleration, correct? So we are given the centripetal acceleration in terms of time t. So your AC will be towards the center, correct? And this magnitude of AC is k square r t square, where t is the time, k is the constant, r is the radius, which is also constant. Now we can write the centripetal acceleration. We know the formula for centripetal acceleration as the speed square divided by the radius. So therefore you will get v square by r as k square r t square. So your v square will come to be k square r square t square. So it implies that the speed will come to me, will get under root RHS. So we'll get k r t, correct? So this is coming to be the speed of the particle. Now you can see the speed is coming in terms of t. K and r are constant, so speed is linearly increasing with t. And if speed is linearly increasing with t, surely you can say the motion will be non-uniform circular motion, because in uniform circular motion the speed is constant. Here your speed is increasing linearly with t. So since v is varying with t, you can say the motion is non-uniform circular motion, correct? So of course your tangential force will also act. Apart from the centripetal force, one force will act towards the center and one force will act along the tangent. Why tangential force act? Because it's a non-uniform circular motion. Okay, and what will be the work done by the tangential force? Or right now we are interested in finding the rate of doing work, that is the power delivered by tangential force. So what will be the tangential force? So we know the magnitude of the tangential force is m dv by dt. So it will be m d by dt of k r t, correct? So we'll get ft as what? M. Now k and r are constant, so they will come out. So it will be simply mkr, correct? It will be simply mkr. That is the tangential force acting on the particle. Now what will be the power delivered by the force? That is F dot v. So in case of the tangential force, the angle is 0. So it is ftv. So we'll get mkr multiplied by what was the value of v? So v came to be krt. So we'll get mkr multiplied by krt. So the power delivered to the particle will be m k square r square t. This is your answer. Of course, this will be the net power. This will be the net power delivered to the particle, because no work is done by the centripetal force. The only power delivered is by only the tangential force. So this is also the net power delivered by the forces acting on the particle, m k square r square t. That is the proof we have to done in this problem. Got it?